This video is part 2 of section 13.1 and will be the shortest of the sections of 13.1. But our goal is to determine an upper bound for an integral. And as we can see here, there's the calculator icon. This entire short section is done using the calculator. The difficult part about that is it depends on your particular calculator. So IB gives 3 options: Inspire, Casio, TI-84. I'm going to show just the TI-84 version, but it also depends on the version of your TI-84 how this works. So it's not a super common thing that you're asked in IB, and as you get better with integrals, if you were taking a full calculus course, this could be done by hand in a few different ways. But we're just asked to do it using technology. I'll show one way in which that can happen. And but you want to check your own calculator, the one you plan to use on the exam, to make sure it works similarly or you're able to make the necessary adjustments. So the question says, the area of the region bounded by the graph of f of x is equal to x squared plus 3, so just a parabola shifted up 3. The x-axis and the vertical lines x equals -1, which is here, and x equals a, some value we're unsure of, but we're told that a is greater than -1, and we can see that in the diagram. That total area is equal to 12, and we're asked to find the value of a. Okay, so before we do anything, we could just set up, similar to what we had done previously in section 13.1, an integral for what it is we're being asked. So we would have the lower bound is -1, the upper bound is a, that's what we're looking to find. The function is x squared plus 3, usually putting that in parentheses is best, and then our variable of integration is dx. So that integral represents the situation that we see graphed here. Okay, and we're asked to solve this using our calculator and a couple features on there. All right, so let's see how you do that. And again, this is going to vary a little bit depending on the age of your calculator. So if we go to a TI-84, what we're going to want to select is this math feature. So I'm going to select math first, and then it's in choice B on my calculator, but just hit the up arrow, and you're looking for this piece right here, the solver. All right, and this is maybe the first time that you've seen this, so you want to, again, look and make sure how it works on your calculator. So let's select the solver. On mine, and ultimately, hopefully yours looks this way, it has a box for equation 1 and a box for equation 2. So what we're going to put in equation 1 is the integral that we just wrote. So the way that we're going to do that is hit math, and choice 9 is function integration. It gives us that integral. Okay, and if we remember what the problem said, our lower bound was -1. So we'll put that in for -1. The upper bound is a in the question, but just use the variable x in your calculator. So that's what we don't know, that's what we're hoping to find. And then the function goes inside the parentheses there, and that function was x squared plus 3. And then just communicate to the calculator that that variable is dx. Okay, so in equation 1, we put the integral with the unknown upper bound. And then in equation 2, we put the value that we were told the area equaled. And in the question it said that the area under this curve from -1 to some value was equal to 12. So go ahead and put 12 in there. All right, and then you're going to hit enter. And this part can get confusing. So it has... the integral needs to be equal to 12, so that's what we communicate to it. And then you need to do one more thing to make this computation actually go. So what needs to happen is you need to tell it to solve it, and the way that you do that is hit alpha and then your equal sign, which right there in green it says solve. So alpha solve. So let's go ahead and do that, and let's see what we get. Alpha, and then solve. It takes a second for it to think about it. It's making the calculation, so it even takes the calculator a little bit. And then it changes to 1.99999, so you can confidently answer that this upper bound, this x value right here, is equal to 2. So the end result of that is the integral from -1 to 2 of x squared plus 3 would give us 12, but the calculator solved for that unknown upper bound.